Thanks everybody for joining. Thanks for taking your time out of your day to join us. I'm Joe Cosentino. I'm a category manager with TDL Gentek, and this is part of our regular ongoing webinar and training series that we like to provide to our customers and partners. Today we have one of our premium partners, Preseem, and a special guest along with them is Tarana, and they're going to go over their products and how they complement each other, and the various manufacturers will get into detail. Please feel free to interject anytime, raise your hand. You can put questions in the chat. It's an open forum, so feel free to ask any questions. We want to make sure that we get you whatever information you need. So just a quick introduction in terms of TDL. Most of you probably know who we are. You're probably either our partner or one of our resellers. TDL has been around for 45 years. We're a large Canadian-based distributor, and one of our goals is to have, of course, the right products in the right place at the right time, and Preseem and Tarana being two of those. As most of you know, we're a national company all across Canada, various locations. We have multiple warehouses in Ontario, across Ontario, and out west as well. So TDL has been around for about 45 years. We recently, in the last couple of years, merged with Gentek, another very mature Canadian company that was also around for about 45 years. So hence TDL Gentek, the two companies have formally merged, and we like to offer a wide range of products. Again, most of you are aware of that. So, excuse me. So we're going to be getting into that, and we won't talk too much about us. We're here to talk about Preseem and Tarana. So Jeremy Austin is a senior product manager with Preseem, and Vardin Amiri is a senior sales engineer with Tarana. I'm going to let them introduce themselves, and then Jeremy can get started.
Thanks a lot. Vardin, you want to go first?
No, go ahead, Jeremy. You're good first.
Yeah.
You're good first.
Jeremy Austin. Yeah, I've been in the ISP industry since the middle '90s or so, and I've been at Preseem for this is my fourth year there, as senior product manager. And for those of you who don't know what we do, we give regional and local operators tools to understand and proactively improve the quality of experience for your subscribers. So we enable operators to understand and improve that experience. We collect a lot of metrics to do so. I'm not going to be showing you the product today. This isn't a product demo. This is something that we do about once a year, where we put out a industry-wide report. We call it the Fixed Wireless Report. Next year is probably just going to be the Internet Report, because we're expanding into more fields than just fixed wireless. We're just days away from releasing our fiber features, for example. Today, though, we're going to concentrate on wireless with, of course, our other guest here has been making a lot of waves in the world of wireless, kind of turning expectations upside down of what is possible. So I'm going to focus on showing how internet metrics have changed over the past year since our previous report, and I'll also give you a little bit of analysis on how the actual vendor landscape has changed as well. I'm going to go ahead and let Vardin introduce himself, though, so I don't monopolize all of our time.
Sure. Thank you, Jeremy. Name is Vardin Amiri. I'm senior sales engineer here with Tarana Wireless. Been in the wireless industry for more than 24 years now. I've worked on proprietary products, Wi-Fi based products, LTE, WiMAX, name it. I've worked on point-to-point, point-to-multipoint, anywhere from 600 megahertz all the way to free space optics. So very familiar with the industry, love the industry. I've been with Tarana now, more than 2 years, getting close to 2.5 years. I love the technology, met the folks, great team. I think we have something unique to offer that allows, our customers or service providers to offer, fiber-like type services over wireless while delivering the reliability, capacity, and meeting the needs of customers. I do have a few slides that I'm going to share with you as well that kind of tells you a little bit about, Tarana, how it's proven in actual deployments. So I'll share that information with you just so you get a good idea.
Fantastic. I do want to point out that we are wanting this meeting to be interactive. Vardin will definitely feel free to ask questions. Joe, we also have Aaron on who can help organize this. Please, raise your hand or use the Q&A feature here to ask us questions. Feel free to reserve them to the end if you wish, but I'm very happy to take questions while we're going along and have this be a conversation. I don't want to just be us staring at charts and being bored. So please feel free to do that. Any other housekeeping, Joe, before I begin?
I think that is it, Jeremy. Thank you.
Awesome. Okay, and on my first slide, just giving you a quick overview. There is a QR code there if you want to get the report, or you can just Google for it for our 2024 edition. The ideas that underlie this report are essentially, because we have a global database of ISPs, well over 400 ISPs worldwide, we have a really good bell curve, a really good understanding of what is healthy for an ISP. There are certainly going to be places where operators are delivering fewer bits. Maybe there's less customer demand, and some places where maybe they're at a kind of a cutting edge, high demand environment with all fiber. We have a mix of all of those things in our database. So we help operators understand, how am I doing versus how the rest of the world is doing. Those can be either quantitative or qualitative measurements, right? When we're talking about latency, you can understand, how are my customers experiencing latency, which is a really good proxy for user experience, versus what is normal in the industry. All this is available in the report. And we collect billions, or probably even trillions at this point, of metrics a day. So we are able to crunch a lot of this down to provide some really granular and high level, both granular and high level reports for you. Actionable data as you are a product user. And of course, this report is free to anyone in the world. You do not have to be a customer to get the full report. I'm also mentioning this because I'm covering just a tiny bit of what's in the report today. I do encourage you to check it out if what I have to share with you is interesting. I'm going to talk about year-over-year comparison. We'll go into service delivery and busy hour online load ratios, what's actually needed in terms of capacity planning at the operator level, wireless market share trends, latency versus throughput, access point RF efficiency, and then at that point, I'm going to hand it over to Vardin, who's going to talk about Tarana's G1 next generation fixed wireless access product, and then we'll get back to any recap and Q&A. So that's what we're going to cover here quickly. 2022 to 2023 is the period covered in our recent report, ending in Q4 23, and we're seeing the active subscriber is now downloading at about 6.5 megabits, up from 6 megabits. That's not the average subscriber. That would be subscribers who are actively using their internet connection. So this will differ a little bit from the busy hour online load, which is kind of the historical metric of how much traffic a customer uses at peak busy hour. And in total, the active subscriber is using about 386 gigabytes. That's up 17% from the last year. 17% seems to really be the number that's been consistent for a long time. Cisco, I think, in their most recent visual networking index, has pointed out that growth year over year has really stayed pretty steady. That sometimes that's growth in total consumption, and sometimes that's growth in the actual busy hour online load, but generally between 10 and 20% is where it has stood for quite some time. As networks improve and applications take advantage of more bandwidth and users spend more time online, that's been very consistent growth. I'm not going to dig into the latency numbers a great deal, but in our database, the caveat that we're measuring our customers whose quality of experience is being well managed. What we can say about our customers is that latency has improved 9%, and I'll dig into some of the reasons for that as we go along. But I'm not going to give you the full chart breakdown of this experience. Next slide here. Okay, we're now going to talk about service speeds and delivery. So when we talk about internet speeds, we're usually referring to the fact that most internet subscribers are subscribing to internet at a specific plan speed. You could call that a service. You could call that a commitment to the customer. It's usually an up to from the subscriber level. in terms of mass market. And we see some really interesting trends going on here. This has been pretty consistent. The one on the left, the chart on the left here, is showing a slope here. The provisioned plan speed in megabits per second is on the x-axis, on the horizontal axis. And we're showing here speeds from at the low end down in the kind of the single digits megabits all the way up to gigabit plan speeds. We're not currently reporting on speeds over a gigabit because we tend to not see very many of those in the fixed wireless industry. Maybe next year we'll see some more of those, as there are definitely people doing 2.5 gigabit plans, and once we have enough of them, then we'll start reporting on them. But the interesting thing here is this slope. This is how much bandwidth is used, the average active megabits per second versus the plan speed. You really have to approximately triple the plan speed to double the usage. This slope has been consistent over the last couple of years. You don't immediately cause a massive surge in demand by offering faster speeds. There will be people who can use them. There's going to be some outliers here, but the average user really doesn't consume a great deal more data, and that's visible by looking at the chart on the right here. I'm going to take my little pen here. So you'll see that if you are serving small plans, say those under 50 or under 100 megabit, under 50 or 75 megabit plans, you'll see that there's some compression going on. The blue line here is the 50th percentile, and so the red being the 80th, the yellow the 95th, and this top line, the green line, being the 99th percentile of how much data is used per month. You'll see that people are constrained by the plan speed. There's very little difference between those percentiles when we're looking at those really small plans. But above about 50 megabits, something very interesting happens, which is that the average user barely rises in the amount of bandwidth that they use, all the way up into the multi-hundred megabit plans, the kind of things that Vardin will be talking about later on that are deliverable over Tarana. You do see in the upper percentile that there's still some increase here until about 200 megabits, and over about 200 megabits, even those heaviest users really flatten off. It's really quite interesting. We've been watching this trend for a few years now, because this factors into a lot of the logic behind how networks are being funded today, how they're being built, plans for the future. The thing that we have yet to see is higher plan speeds really drive a significant amount of additional demand. They can drive faster instantaneous speeds, get on the internet and get off. You're gonna be able to do things faster, but that doesn't necessarily mean you're going to do more of it. From there, let's talk about what happens when we're looking at the peak busy hour of the day. This is the kind of the period that if any of you are operators and you have been serving internet for a while, you understand that the most busy time of the day is going to be in the evening hours, and that's when your network is going to be at its busiest and most congested. If you have any bottlenecks in your network where demand is outstripping supply, you're going to have a reduction in the quality of experience for the end user. So we look at this and we say, okay, how much internet do we actually need? How much bandwidth do we need when we're doing our capacity planning? Because we already learned that it's going to grow by 17% year over year. So we definitely have to be doing our long-term planning. And when I'm designing a network today and I say, okay, I want to put in a new network and it needs to, I need to be able to run this specific equipment with this many customers over X many years, it's important to know these numbers so you can understand, okay, I can see what people are going to use now. What are they going to be using 5 years from now, since we know that these trends are pretty stable. Today, from a capacity planning perspective, we'll see that most operators, these circles here are bundled by ISP, and the size of the circle kind of indicates the size of the ISP. You'll notice that most operators are seeing right about 4 megabits per second. I'll draw a line here. Right about 4 megabits per second per subscriber, not per active subscriber, but per revenue generating subscriber. This has been pretty consistent. Last year, I think the number would have been 3.3 or 3.4. So we've seen steady growth here. But what is normal still incorporates a wide range of values. We see some operators who are delivering a really good customer experience down at 2 megabits per user. That's unusual, but it is possible. Similarly, we see some outliers who are delivering, their customer demand is closer to 10 megabits. But as you can see, that's kind of off the end of the bell curve. It would be unusual today for you to need to plan a network where you were expecting that your busy hour load today would be 10 megabits per subscriber. On the y-axis here, we see the upload busy hour online load, and that is still holding right at about a 9-to-1 ratio. If we draw a slope through all of these lines, and we can see what that slope would look like. I'm going to erase let's get rid of some of these things here. Okay, here we go. If we draw a line through this, you'll see that the line has about a 9-to-1 slope. It used to be that we were expecting 10-to-1 to be a reasonable expectation. Like you could sell a 10 megabit by 1 megabit plan, and you'd be able to keep people happy. Today, there's a lot of push toward selling symmetric plans. 100 by 100, 200 by 200, where there's as much upload as there is download. User demand doesn't really require that at present. In terms of future proofing, we are seeing this slope come down. I would expect to watch it go more toward 8-to-1 or 5-to-1 in maybe a few years' time. We'll see next year exactly what it's hit, but my bet, putting on my little prediction cap, would be that we'd see a slope closer to 8-to-1 next year. In terms of instantaneous user demand, it's really nice to have a plan that's got a lot of upload speed, particularly when you come back from vacation and you have just taken a bunch of video and you want to upload it. But in general, most people don't need a huge amount of bandwidth today in the upstream direction. I'm going to move on to the next slide. Okay, let's talk about vendor market share changes and latency versus throughput. So with the caveat that this chart is showing what Preseem sees in terms of vendor market share. This is not a survey. We've not surveyed operators to say what equipment have you decommissioned and what new equipment are you buying. We're looking at the equipment that's actually deployed in the field. So these numbers are not intended to be gospel across the entire industry. We do have a significant chunk of the industry as our customer base, and we have seen some pretty consistent trends. So we believe that it is predictive of the market as a whole. There are some really interesting trends in this past year. One is kind of a significant downturn in the 4G equipment, so buy cells and Telrad. There's not enough 5G equipment yet for me to make a prediction about that, but we're definitely seeing a reduction in the marketplace there. Interestingly, Cambium and Ubiquiti kind of reversed roles a little bit, where we're seeing a reduction in the total amount of Cambium CPEs. However, there are still Cambium APs being deployed. There's still a positive trend there. So I'm not entirely certain, what's being swapped out here, but I think we can make a guess in some cases based on some of the information that Tarana is going to be giving us. Ubiquiti is still doing really well here with an increase in the marketplace, 2.5%, of CPEs. But however, we are seeing an overall downturn in terms of the total number of APs deployed by Ubiquiti. Historically, Cambium has had a smaller percentage of the market for APs because they've been a higher density provider. You've been putting more CPEs per AP with Cambium's deployments, with things like the ePMP platform and the Vidusa, the 450M platform that support really high density deployments. And Ubiquiti has typically dominated in lower density deployments. So I think that's still the case. I know Ubiquiti is doing well in 60 gigahertz. Those tend to be lower density deployments, which also helps explain some of the downturn in total number of APs for Ubiquiti. Tarana has been doing really well since we first started reporting on them. The previous year in 2022, they had not quite hit 0.5% in the marketplace, and now we've seen about 5 times that in the past year. Some really rapid growth with an increase in 1.5% in the total marketplace. So some really interesting, significant improvements there with penetration by Tarana. I expect to see that continue to grow over the next year. I expect to see that slope be even steeper in our numbers. And I'll explain about this a little bit further on. In our Preseem product, we have a number of things that we can do to actually manage equipment, and even without full support for Tarana today, which we can report on quality of experience, but there's some things that we're still missing from Tarana, and even so, we would expect to see those numbers grow once Preseem has better support for Tarana. Vardin, do you have any questions about this chart while we're here?
Sorry about that, I was muted. No, I think it's pretty good. You covered it pretty well. I mean, the key point that you mentioned in the beginning was that this is data that you see of devices connected to Preseem. It doesn't necessarily give you a picture of the entire market, right? It's
That's
what
correct.
Preseem sees, as far as growth or strengths. Yeah. Exactly.
And similarly, when we're talking about the that user experience side of what's driving these market trends, remember I said we're seeing a reduction in on the 4G LTE. If we look at these two this is Telrad and Bicells. I'm showing you here 2 percentiles for latency. On the y-axis, we're showing the 5th percentile of latency. So that's the idle latency, when the equipment is not under load. Like, what's the best case scenario latency that we're going to get out of that payload as it goes through our access network? And then on the x-axis here, we're seeing the loaded latency. What happens once we actually load these things up? With LTE, there's a minimum latency. We're seeing almost 25, about 22 milliseconds of latency that's just inherent in the product. And that's something that the market has decided that is really, not in the best interest of the customer experience, as well as efficiency numbers. We'll get into that here in a minute. So we are seeing a downturn in 4G. I think we first started seeing 4G in the market fixed wireless market about 7 or 8 years ago, and it seems like we've reached the end of life, end of useful life for that particular generation of technology. Of course, 5G with its new radio has a lot of low latency capabilities, and we should expect to see that in the fixed wireless market at some point. That's been a little bit slower to enter than maybe we've liked. We like to see better and better performance. If we look down at this side here, you'll see that the 60 gigahertz stuff and LTU Rocket, those are both Ubiquiti. Those have really good numbers for both idle latency and loaded latency. We'll learn a little bit more about that in a couple slides when we start looking at real world capacity. The rest of the manufacturers are kind of clustered here. So I'm going to draw a little kind of parallel lines here, and you'll see that very similar latency between Medusa, that's this product right here, the regular PMP 450, and then this is one of Tarana's lines. I don't remember whether that's the CBRS or the 5 gigahertz line, but you'll see that the idle latency is pretty close. 5 milliseconds for Medusa, closer to 10 milliseconds for Tarana, but under load they're almost identical, very, very similar. Then we see some clustering for some of the older Wi-Fi based chipsets. So like Rocket Prism here, there's a MikroTik in there. These here are kind of Wi-Fi based, as is Mimosa, the A5C right there. So, and you'll see that they're all clustered pretty close together. I would not call this a huge significant difference in the vertical access, basically 5 to 11 milliseconds or so. We do see some difference though in terms of what happens under load. As you can see, Medusa and Tarana are definitely performing the best under load in that group. The further to the right here is worse performance in this particular case. So the ePMP 2000 showing a little bit similar to the 3000. There's not quite enough 4000s to show them on this chart yet. Those are kind of coming into the market. All right. Now let's talk about real world capacity. So we have a couple different ways to measure capacity. One is that we actually measure the payload that's going to the end user. And that is something that is unique to Preseem. We measure the payload going through an inline appliance. We also measure things like the number of connected stations, and we do that by actually polling the equipment, the KPIs off the equipment. And we can also do things like measure the statistics that the equipment gives us for link rates and overall efficiency. We'll talk about that in a minute. So if we look at connected stations here, I'm showing you the light blue is the average number of connected stations per AP. The dark blue is the P95, so that's the 95th percentile. And then the maximum value that we see would be the maximum one in our data set. We had seen, I think a year or two ago, we had seen some Cambium Medusa radios that had like 183 clients connected, I think. And as that consumption grows, 17% year over year, we would expect to see the number of connected stations drop, because you can't, once the radio is at capacity, the only way that you can continue to deliver more bits to your customer is to do it with fewer connected subscribers, because we know that growth is going to continue. You can't continue adding subscribers as usage grows. So you'll see that there's a lot of kind of clustering here in this data set. The Wi-Fi based chipsets are pretty common here. I'll just kind of draw a circle here, kind of in the 7 to 10 range of the average subscriber. In fixed wireless, as in many types of networks, there is kind of a logarithmic distribution where you have density follows a logarithmic curve. So you end up with a lot of radios that don't have very many stations connected to them. This is one of the things that Ubiquiti has excelled at. Wide coverage with not, in low density environments that are rural. You can use inexpensive equipment and cover a lot of area and still provide a good quality of experience. However, in the denser areas, you've needed other tools. And as we look down the chart, we can see that how some of those other tools are doing. The Tarana numbers are what I would call still entering the market in terms of market maturity. When we first saw, our first numbers that we saw from Tarana were deployments that were deliberately designed to max out the APs as extensively as possible and cover a lot of customers. Now that we have more, many more Tarana base nodes deployed in the marketplace, the average number of subscribers per base node has come down, as we would expect. I would expect to see this number go back up as we have more maturity in the marketplace. It takes time as an operator to go out and saturate an environment with new subscribers or with upgraded subscribers from older equipment. So what we are seeing are very healthy numbers here on the maximum side. Almost right up there with Cambium. I expect that we'll see those numbers continue to grow as well as people add more subscribers in the actual field. The P95s here are very similar for Medusa. However, this doesn't tell you the whole picture, what these customers are actually experiencing in terms of throughput. So I'm going to move on to the next slide.
Just one thing I wanted to just mention.
Sure.
So the Tarana, the one with the 141 number is actually the CBRS platform, and the 134 is the 5 gigahertz. And obviously, it's not captured here because those customers don't use Preseem to manage a network. But the largest number of RNs or subscribers we have connected on the 5 gigahertz was 187, offering 100 by 20 megabit packages. And on the CBRS, we hit 209 with Excellent. An operator offering 100 by 20. One question for you, Jeremy, is you showed the trend on the Wi-Fi equipment, and majority of those Wi-Fi equipment use 802.11 AC. Do you see any change with AX in terms of subscriber count per AP, since it's based on a Wi-Fi chipset? What are your thoughts?
I would expect to see more. Right now, the reason that that's not on this chart is that the equipment really hasn't had enough saturation in the marketplace to be predictive. It's not just a matter of getting coverage out there. It's also about connecting subscribers. So there's a ramp up time for a new technology to get to the point where we feel like those numbers are actually representative. In fact, we watched that ramp up time. I think the first year that Tarana was out, we didn't report these numbers for Tarana because we didn't have a big enough sample base. So and the same is going to be true when I show you the spectral efficiency numbers. The AX equipment there's just still not enough of it for us to be really happy with saying that it's predictive. It has to be in the marketplace for some time. And I don't know it's not a hard number. It's not like we set a date to say, okay, from the date that we see the first piece of equipment here, we're going to count, 180 days or 720 days or whatever that it would be. We look at in terms of what percentage it is of the total total subscriber set. That's under the assumption that operators are going to attempt to maximize their return on that and really load at least some of them up. Does that make sense, Vardin?
Yeah, I would just, it's curiosity, right? Because again, based on a Wi-Fi chipset, curiosity is, how much different would it perform from the AC chipset going to an AX chipset?
I've got a little more for you. I have a little more on that in just in 2 slides. So I'll come back to that question. Okay, now we look at the actual throughput. So we talked about looking at connected subscribers. That was the previous chart. Now we're looking at the actual access point download throughput during peak. And in this case, again, this is a case where I'm not showing you the maximum value. I'm showing you here's what is possible at the the average and the P95. The average. So if we go back and look at those average numbers for, let's say, if we expect that the average base node for Tarana has 14 to 17 subscribers connected, you'll see that number, you multiply that number by approximately 4, and that's going to tell you your average value at peak as well, because the average subscriber is going to be consuming some right around 4 megabits per second. So again, we see this you see some older equipment here, like the Light AP. It's a little bit lower here. Bicells, there's our 4G gear, and then we have the AC gear. So I'm going to draw a line kind of through. Let's see, there's Wave. So let's do like that much there. Very, very similar experience in terms of if it's the same generation of technology, there's really not a radical difference between even different vendors. Once you start loading them up, you're going to be seeing very similar performance numbers out of them. There may be other reasons to choose one vendor over another. That's why it's really nice to have folks like TDL who can and TDL Gentek who can help you understand, okay, what's the best equipment for my particular deployment. What does make a step change, though, is when there is a new technology here. So LTU, for example, that's an example of a proprietary protocol. Definitely, we see higher peaks there with that. There will be a little nuance to that in the next slide. ePMP 3000, again, outperforming the say Rocket 5 AC Prism. I don't think that this is a surprise to anyone who's been in the market. Not a huge amount. We're seeing 31 versus 37. There are also decisions about how dense am I going to put. This is what the operators are doing. This is not manufacturers' recommendations, right? This is once you actually get a mix of users in the field with a mix of modulations, what can we actually deliver to them? Interesting that the P95 on these is all still kind of mostly under 100 megabits, right? Then we have kind of this last class, the Medusa and Tarana. Again, I'm expecting to see those Tarana's numbers continue to grow because we know that those radios are not saturated yet. Vardin will talk a little bit about that in terms of what's capable from a multiplexing perspective. With Cambium, we tend to see a gain of about between 1 and 3. So if you take an individual subscriber's link rate, what's the total amount of capacity that you can pass over the access point? In general, the average AP is passing twice as much as an AC-based chipset, and that's going to be true for both of these. I'm going to move on to the spectral efficiency. So then the last thing that we're going to cover here, this will be my last slide before I wrap up, is what does this mean in terms of how much spectrum is required? So for example, when I first deployed Mimosa, they were the first product in the WISP space really to handle 256 QAM. That's these A5Cs here, 256 QAM. They got to market before Cambium did, and you could deliver relatively fast speeds, but you had to consume more spectrum in order to do so. You could do wider channels than you could do with other equipment. Obviously, as the channel width rises, your total efficiency goes down, so you do have to balance that out. So what we wanted to look at, and this is actually the first year that I produced this chart, is what is the actual spectral efficiency of these vendors that have some maturity in the marketplace. I did include, so I'm gonna come back to the 4600 that I was talking about here, this series here. I included this for comparison's sake. It is still early days on the 4600, so I'm not certain that we won't see a little bit less of a downward trend. Let me explain the chart here first before I get into the weeds on that. So this x-axis is the number of connected CPEs from 1 to P95. So that's saying, okay, how many APs, how many CPEs is it practical to put? That, remember, that median is going to be much lower. That average is going to be much to the left here. So for example, on the Mimosa A5, that average is going to be, whatever it is, 14, somewhere around there. The thing that's interesting is, does this line go up or down as you add more subscribers? And invariably, when we look at these Wi-Fi based chipsets, although maybe not that Mimosa one, we do tend to see a reduction in efficiency as the number of subscribers increases. It's diminishing returns here. Like the EPMP 2000, we're starting at the y-axis here is this is efficiency in bits per hertz. So how much spectrum am I going to need in order to deliver? If you're talking a 10 hertz wide channel, and if you can deliver 100 megabits through that, then we would refer to that as a spectral efficiency of 10 bits per hertz. So that would be right up here at this top. In the real world, it's actually pretty hard to achieve 10 bits per hertz. It costs more and more to get incremental gains, and as you go up in modulation. There are some exceptions to this overall downward trend. AirMax AC holds pretty steady up to just about 23, 24 CPEs. It's really not practical with some of these Wi-Fi based chipsets because they are contention based. It's really not practical to go much higher than that. In fact, my experience with some of the better operators in the WISP space is that they really heavily control the number of subscribers that are on their access points. So I know one operator that has impeccable customer experience numbers, and they really, on those Wi-Fi based chipsets, they don't allow more than 14 or 15, which would be kind of the 60th percentile or so here. And because they're so rigorous about it, they have just fantastic customer experience. But there's some interesting chipsets that I want to talk about here. So for example, the PMP 450M, the Medusa, because this is the MU MIMO, it rises, total efficiency rises as you add more subscribers. It's not a dramatic rise, it's not a doubling, but it does rise because you have more opportunities to multiplex data together. I want to point out here, this is the line for Tarana, and Vardin has pointed out that this is for a single remote node, this efficiency. This is not the full node efficiency. If we were looking at the full node efficiency, for one, this line would be considerably higher, and it would rise as we add subscribers. Vardin, any comments about that?
No, that's accurate. Yeah. So obviously the RBN is capable of, it uses 2 by 40 megahertz channels delivering 2.4 gigs. Now, when you look at the spectral efficiency on a BN with 6 streams, it comes down to 30 bits per hertz. But we notice in real world deployments, obviously, you're not always operating at the highest order of modulation, right, separation, and all that. But we tend to see greater than 20 bits per hertz on a BN. So average is roughly about 2.5.
Yeah, that would make sense, because if let's say that we're transmitting to 3 subscribers simultaneously with 2 chains, which would be quite easy to do, then we would expect to see that number to be considerably higher. So that's the caveat here for this line, that it is showing you the spectral efficiency for a single subscriber, which is why it's flat in this chart here. For Medusa, yeah, we do see an increase. Let's see, other interesting things. LTU has a pretty steep decline here, and that is consistent with what we hear in the field, that it does have some of the highest efficiency for a single subscriber, but it does not sustain that as you add more subscribers. And in fact, it doesn't really get you any more, excuse me, it doesn't get you more customers. It gets you the ability to deliver faster plans, but not necessarily to more customers in one deployment, which is why you see that kind of peaking out here in the low 20s, just like you do for some of the Wi-Fi based chipsets. That's been a really interesting thing. Okay, my last wrap-up slide. I really don't want to dominate the time here. We are seeing 17 to 20% increased use across the board. Latency is still improving, which I think is fantastic, that operators are putting the effort into making sure that they're paying close attention to the quality of experience of that end customer experience. And they are removing older equipment from their network that can't deliver those speeds and that quality of experience. We went over kind of the vendor progress and growth, how plan speeds are growing year over year. And then my last caveat is just plan your coverages by capacity. How much capacity you're actually going to be needing to deliver to your end subscribers. You should be able to run those numbers and figure it out. It doesn't have to be a terrible mystery, particularly if you're already in the space. If you're already an ISP and serving, you know what your customers need. You're going to be able to run those numbers. And when you're evaluating new equipment, you'll be able to say, is this the right equipment for this deployment? The cost, you can think of it in terms of cost per square mile per megabit per hertz, right? Are you going to go? Are you operating in an area where you need a low cost equipment with very low density, or are you going to go with higher density deployment with more expensive gear? And with that, I'm going to hand the controls. One last plug. For the fixed wireless report, there's so much more in the fixed wireless report that I could not get to today. Upload statistics, that breakdown of subscriber latency. We talk about oversubscription, how operators are managing that, throughput by channel width, how operators are choosing their channel width. Please feel free to go get that, and I'd love to hear your feedback on that if you have any questions. Vardin, it's all you.
Sure. Thank you very much, Jeremy. Appreciate that. Good work, nice numbers, great report. So as far as Tarana goes, we obviously, we have a solution which is called the G1 product. It's based on our next generation fixed wireless access, and we've been deploying this for quite some time now. Over about 2.5 years of deployments, and we now have sufficient amount of data out there where we can actually show customers that this is what we're capable of doing. In this case here, what we've done, we've taken 50,000 live links from our network, right? There's 50,000 live links. We've taken 25,000 from our CBRS product line and 25,000 from our 5 gigahertz product line. And when we actually graph these based on link length as well as performance, where the y-axis is performance in megabits per second on the downlink, and on the x-axis it's the link length in miles. So if you look at that, you'll notice that we do have subscribers out there that deliver as much as 600 megabits on the down, and then depending on the technology you look at, whether it's 5 gigahertz or CBRS, at 10 miles we're delivering 200 on 5 gigahertz and over 350 megabits on CBRS. So overall average of all these links, 50,000 links, you're seeing roughly about 414 megabits per second down, 109 megabits per second up at an average distance of 3.1 miles. These are actually live links. This is what's being delivered in networks today. And if you look at the chart at the bottom, we have the number of links in half mile increments for whether it's CBRS or 5 gigahertz. But you'll notice that our lowest data rate up to 10 miles for these 50,000 sample links is 200 megabits or more, right? On the 5 gigahertz, using that as in an environment where there's a lot of congestion, interference, and we're still able to operate and deliver those high capacities needed to meet the minimum requirements. Whether it's 50, 10, 120, 100, 100, 200 megabits, 300 megabit, we deliver those. We have customers that deliver 500 meg packages to their customers today. Now, if I go to the next slide, which provides a lot more color to the 50,000 links. So 25,000 as mentioned on the CBRS side, and roughly 25,000 on the 5 gigahertz side. So if we look at the chart here, the x-axis is the path loss above free space. So it's broken up into 5 dB increments. So anything above free space obviously means there is some kind of a near line of sight or non-line of sight. And the way we've broken it up is anywhere from 0 to 15 dB above free space path loss, we assume as being near line of sight, and anything above that we consider as being non-line of sight. And then we have the y-axis, which is the interference level that we measure basically for the links. So if you look at the chart on the left-hand side, where it represents 3 gigahertz, you'll notice majority of the links are along the near and non-line of sight type deployments, and the interference level is anywhere around 0 to about 20 dB. And this is mainly in the US market where you have CBRS, where you have PALs and GAA. So the interference most likely is coming from folks who use the GAA spectrum, as PALs are protected. Now, when we look at the 5 gigahertz side, you'll notice it's same chart, but 5 gigahertz spectrum. You'll notice that majority of the links operate in an average interference of roughly about 25 dB, as compared to about 14.5 dB for CBRS or 3 gigahertz. And then you'll notice majority of the links are anywhere from line of sight to just about where non-line of sight begins, which is where the average is. But there are also significant amount of links that are in non-line of sight. And non-line of sight obviously could mean foliage, buildings, all different types of clutter data. The beauty is that you'll notice that we have links as far as in near line of sight experiencing, greater than 40 dBs of interference on the carrier. And we're yet still able to deliver those high capacities of, as you saw in the previous chart, 200 megabits above. Those same links used on the previous chart is what's used on this particular chart. So these are real live links, real performances. This is what we actually see, or this is what the Tarana G1 platform sees. So near line of sight, non-line of sight, despite those, we still deliver high performances. But as you can see, the trend for the CBRS as well as the 5 gigahertz. And remember,
question about this, Vardin.
Yes.
I'm sorry, I didn't realize you're quite done.
Okay.
This is about this chart in relation to the previous slide. Can you go back there for a second?
Sure.
So, because as we observe, the lighter gray is the 5 gigahertz, and it definitely falls off more steeply. How much of that is due to just the higher output that's available, higher output available in CBRS, and how much of that is due to increased noise?
Good question. So
I wasn't sure if I could quite figure that out from the next slide.
Sure. So what you can see here, so obviously CBRS gives you, significant more dBs as compared to the 5 gigahertz, and 5 gigahertz operates in a more congested environment. Now, obviously, it's very hard to say how much is it, when you're looking at so many links at the same time, right? Because on the 5 gigahertz, I'll be spending more time canceling out interference to deliver the higher capacities, and I have less power, so I may not be able to go as far. Now, one of the things that you will see in this chart is that at the same distance, CBRS is definitely higher, and that could be due to the higher power, right? When you have higher power, you have higher SINR. You have higher SINR means higher performance. Therefore, you can deliver higher capacity. So you can look at higher power in terms of more distance or higher capacity. Since the distance here are fixed, we're not going beyond 10 miles, majority of it could be due to the power level. And there's also a little bit due to, the cancellation that we have to do less on CBRS versus 5 gigahertz. Did that answer the question? It
does. Thank you.
No worries. So having said all that, Tarana has come out with a 6 gigahertz flavor of the G1 platform. So we've had the 3 gigahertz CBRS, the 5 gigahertz, and now we've come out with the 6 gigahertz. The hardware has been released end of last year, Q4 of last year. The beauty with the 6 gigahertz spectrum is that it gives you an additional 850 megahertz of more spectrum in the UNI 5 and 7. And if you're in Canada, it also includes the UNI 6. One of the benefits Tarana brings to the table is that it gives you, our current products support 2 carriers. The 6 gigahertz will support 440 megahertz carriers, and they don't need to be contiguous. So it's going to be a lot easier to find 6 gigahertz spectrum that is currently used by incumbents for point-to-point. It's going to be easier to find, 40 megahertz chunks versus a complete 160 megahertz of spectrum to deliver gigabit type capacities. And here's an example of a live link. We've had, significant amount of these units out in the field, but here's one that I decided to show during this presentation: 981 megabits down, 567 megabits up. Look and feel, everything will be identical to our current product line, but the beauty is that the same technology, whether it's interference cancellation, near non-line of sight performance, all that exists here, as well as frequency reuse of 1, right? So you're going to be able to use the same 4x40 megahertz channels on your entire 4 sectors at a given site. So very exciting. We're excited with this platform, and it's delivering, better performance than expected in customers' networks. Oh, it's not. I can't seem to. Okay, there we go.
There you go.
There, it wasn't going to the next slide. So I got it there. In order to be able to do what we do, you definitely need, next generation fixed wireless access technologies. And some of the fundamentals there is being able to operate in near and non-line of sight. You got to be able to take, multiple paths and integrate them, and being able to add all those and get a better signal level and higher capacity at any given location. You also need, interference cancellation, not mitigation. You have to be able to cancel it. There's only so much you can mitigate. And typically when you mitigate, what happens is you result in smaller channel width, lower power, affects performance ultimately at the end. And for us to be able to do all this, you need to have independent radio streams, whether it's on the base station side or BN side, or on the subscriber side, which is the CPE side. You need those multiple streams or chains of radios to be able to do the multipath integration, to be able to do the interference cancellation, to be able to do the nulls that we've covered in the last few slides. So that's what I had to share with you. We're open to questions. I don't have any more slides, but if anybody has questions that would like to ask, be more than happy to answer them.
Hi, folks. Is there any questions we have?
I'm not seeing any hands raised, but by all means, type them in the chat or the Q&A if you have any. And if not, this webinar is being recorded, and
we've got one from Sam.
Oh, wonderful. Let's go to the chat.
Slide 16. I think I'll take that one. Sounds good for me.
Go for it.
Okay, so this is the max CPE a one-time max or an average of minimums? AP performance when loaded. Yes, you're right, Sam. Okay, let's talk about this from a performance perspective. We don't have a ton of time here, but you're right that there is a significant performance curve about AP loading. When I talked about a customer deciding not to heavily overload their equipment in terms of the total number of subscribers, that is significant, and different types of equipment handle that differently. We would like to put out the analysis for that. It is a significant amount of number crunching. There's a good deal of just noise. There's a lot of noise in the data. So in order for us to be able to make good recommendations about what the optimal number, it's not going to be just a single optimal number of CPEs. It's also going to be CPEs at a particular performance level, and then include the actual demand. Is this operator one that has a higher busy hour online load than others? So if we can find a way to distill that down to a simple 2-axis graph, we'll do so. Right now, that's a complicated thing to represent visually. It's easier to understand in a 3-dimensional space, or to be honest, even a 4-dimensional space. So to answer your previous question, is it a one-time max, or that's going to be just the maximum that we see in our data set over we generate this data over a 2-week period and extrapolate that out to a month. So that would be the maximum that we have seen within that 2-week period. It's fractional though, which is a little bit confusing because it is then averaged out over those 14 days. So it's a little bit confusing. I should have rounded. Hope that answers your question, Sam.
Any other questions, folks? All right. Well, I guess that is it for the webinar. I want to thank everybody for attending. We appreciate your time. I'm sure you will have some questions after this as it comes up. As Aaron stated, we will have this recorded. If you have any questions about Preseem, about Tarana, please feel free to contact your TDL sales team and we'll be happy to assist. And if you want to set up a one-on-one with each of the vendors, we're happy to do that. So again, we thank you for your time, and this concludes our webinar. Thanks, everybody.
Thanks a lot.